Alright, hello. I'll do my electricity for physics again today. Oh my god. And this is the second one. I'll do two videos again, but they're on a different topic technically. So, yeah. Okay. So this question says, in an experiment on electrical current, a circuit, the technician represented the data collected in the graph below. So the graph, oh my god, okay. Here's the graph. So here is 0 to 9. Here is 0 to 8. And it is a potential difference and current. And so it goes like around like that. And this is around, we'll do it like that. That's 3, that's 6, and 3, 4, 5. So 4's around here, goes like that. And right here, wait, don't need that. So at 6, it's at 4. Yep, that looks right. So part A asks us, over which current range does the component act as an ohmic conductor? So for the component to be an ohmic conductor, the graph should show a linear relation. So I drew really badly. From my one, I can see that the point passes through around. It's pretty close to 6 4. So I'll take 6 4. So that means the range will be between 0 and 6 amps. Okay, and part B asks us that calculate the resistance of the component in the ohmic range. Okay, so basically we just use the formula, which is V equals IR. We get the V, which is 4 in this case, because 6 and 4 so together, so it'll be 4 equals, we don't know the resistance, we want to find the resistance, but the current is 6, so that means the resistance equals to 2 over 3. Omega, okay. Now for part C, explain what happens to the resistance of the component at higher currents. So we can go back to the graph. So higher current, like for example 9, the resistance, which is the gradient, oh my god, it's gone. Okay, so because that R is V over I, which is rise over run, which is the gradient, the higher the current, the greater the gradient. So we can say that the resistance will increase. And for part D, what could cause such a change in resistance? So for the resistance to increase, we can say that temperature increased, causing metallic lattice to vibrate, increasing increasing friction and collisions of the electrons or protons if you're using convention. I don't know, probably electrons. We just say electrons. Okay, for the next question, let me find it. For the next, okay, now we're done for the last question. For the next question, it says that one way to make a set of fairy lights is to connect a number of 12-volt lamps in parallel and run the set from a 12-volt transformer. Alternatively, several low potential difference lamps may be connected to in series until the combined potential difference across the lamps match the power supply being used. For example, you can connect 20 12-volt lamps in series to a 240-volt supply. This arrangement is shown in set A. A third way is shown in set B below. Both set A and set B are made up of 15 lamps, and each set dissipates a total of 60 watts plus each lamp. Thus each lamp in either set is rated at 4 watts. Okay, set A looks like this with the 15. Okay, you know what, I'll draw properly. With the 15 across there like that. Oh my god. And then that's set A, set B. Oh, set B looks like that. So it's like okay. And yep. And for part A, it asks after being connected to the 240-volt supply, one lamp in each set burns out. Describe and explain the effect of this operation of each set of lights. So this is obvious. So set A will completely stop working. Set B will set B okay. All lights. Oh my god. Oh my god. Okay. Also lights in set A. Rest of lights in. This is part A. Rest of lights in set B will keep working. Okay. Now for part B of this question, it says that calculate the resistance of each lamp connected in series in set A. So because of the formula of V equals IR, we need to find V and I of each light to find the resistance of each light. So for each light connected in set A, so set A each light. So we'll know that we'll find each lamp in volts. The volts given to each lamp in series is because of the same lamp. So it must just be, because it's 250 volts, it'll be 250 divided by 15 because it's 15 lamps equals 16 equals to 16 volts for each light. And then because the currents are the same in all the lights inside a series circuit, we just have to calculate this the current of the total circuit, which is given because we're given the power. We can use the power equals VI formula, which means so 60 watts equals to 240, which is the volts, times I. That means I equals to 1/4 amps. So that means resistance R of each light will then equal to because V equals I R, we can find out because it becomes 16 equals 1/4 times R, which means the resistance equals to 64 ohms. And for part C, it asks us to calculate the resistance of each lamp connected in parallel in set B. So then we have to find that the same again. So that means we'll find the voltage of each volt of each lamp equals to Just 240. Okay, that just equals to 240 because in parallel all the volts are the same. Equals to 240 volts, and the current, just write V. Each lamp equals 1/4, which is calculated here, divided by 15, which equals to 1/60 amps. And now we have those. We can calculate the R of each lamp equals to V equals I. R, that means 240 equals 1/60 R, which means the resistance equals to, calculator, so it'll be 240 times 60, which is 14400 omega. That's it for part C. And part D, we are asked that the user wants to replace the burnt out lamps. By mistake, the lamps are interchanged. That is, the lamp from set B is placed in set A and the lamp in set A is placed in set B. Describe what is likely to happen in each set when turned on again. Explain your reasoning. Okay, so let's first see what happens in set A. So set B lamp is placed. So in set A, we know that each lamp is at 64 omega. When you put a 10,000 omega one inside the set, the resistance is gonna be really high, taking all the current from the rest of the lights, which means all lights will be very dim, caused by high resistance set B lamp. And now we do set B, which means where the set A lamp is placed. Okay, now see what happens there. So all the resistance are that high because of the voltage really high. When you put a light of low resistance, that's gonna create when you pass 240 volts inside it, it's gonna create lots of heat, and it's probably not gonna work. So set a lamp in circuit will overheat and probably will burn out again. Probably burn out, and because of its low resistance in a it's a high voltage circuit. All right, that's it for the questions for physics today. All right, bye bye.